This is a short tutorial about combustion equations. Now, combustion is the same thing as burning. So we'll see combustion, anytime we have something burning, that would also be called combustion. For combustion, you need to have a fuel, and you need to have some kind of an oxidizer, usually oxygen, and a heat source, some kind of energy source to kind of get it started. Most of the time we're talking about hydrocarbon fuels, carbon-hydrogen compounds, but it doesn't have to be that way. But if we do start with something that's a hydrocarbon, gasoline is a hydrocarbon, methane and ethane and propane and butane you've heard of, those are hydrocarbons. When they do, then the carbons and the oxygens turn into CO2, and the hydrogens and the oxygens turn into H2O. But you could also burn things like, just if you're burning hydrogen, then it mixes with oxygen and it turns into water. And could be, you had to balance like this. Or if you had a sulfur compound, it might turn into SO2 instead of CO2. Now, let's take our example. Here's propane. Okay, the picture down here in the bottom is showing, the nice flames that we get with propane. Really pretty little blue flames, very efficient kind of a fuel. And we can see up here in the top, here's our structural formula, showing we have 3 carbons and it's associated with 8 hydrogens. Well, just looking at this formula, we have a couple of terms we ought to kind of get out of the way. So when we're talking about these little numbers that are down, those are subscripts. And those tell us how many atoms. So we have 3 carbons and 8 hydrogens in that molecule, 2 oxygens in that molecule, 2 oxygens and 1 carbon, and 2 hydrogens and 1 oxygen. And again, it's pretty obvious that, we don't write in the ones for places that are ones, but we know that they are there. Now, the other thing that happens here is that we are going to put in numbers, and these are called coefficients. And I think you use the same term in mathematics, when we need to put a number in front of something. So, the big rule is that to balance an equation, we have to have the same number and kind of atoms on both sides of the equation. So, if we have carbons and hydrogens and oxygens on this side, we have to have the same number of carbons, hydrogens, and oxygens on that side. And the reason is that it's the same atoms on the left side as they are on the right side. Now, over here on the side we have, let me clear it up. Okay, over here on this side here we have propane, and propane has 3 carbons. So let's just pretend we put a 1 right here. If I have 3 carbons on my left side of my equation, then over here on the right side, I also have to have 3 carbons. Now I'm going to put a 3 in front of this. Now that also gives me a bunch of oxygens, but I just want to concentrate on one element at a time. So if I say, looking at my carbons, I have 3 carbons on the left, I have 3 carbons on the right, so my carbons are balanced. Okay, now since I put a 1 in front of here, then let's go ahead and look at our hydrogens. And I have 8 hydrogens. So if I have 8 hydrogens on the left side of my equation, then I'm going to have 8 hydrogens over here. Now, it would not be fair for me to change this molecule, but what I can do is put a number in front. And it might be pretty obvious that if I put a 4, then it gives me 4 times 2, 8 hydrogens on the right. So I've got 8 hydrogens, 8 hydrogens. My last thing to do is my oxygens. So here I have 4 times 1, I've got 4 oxygens here. I've got 3 times 2, I've got 6 oxygens here. And 6 plus 4 we know is 10. So that means 10 oxygens on the product side of my reaction. So there must be 10 oxygens over here, nothing in the propane, but it must be right here. So if I have oxygens coming in 2s, then obviously I need 5 of those to make my reaction balanced. So my final equation is 1 C3H8, 5 O2s, 3 CO2s, 4 H2Os. I'm going to clean that up a little bit, and we would just write 5, and we would write 3, and we'd write 4. And that would be our balanced equation. Now let's practice a little more. We can see what's going to happen is here's C5H12. Now, on a problem we would say, okay, write the combustion equation for C5H12. You have to know to put in the oxygen, so memorize that. And it's going to turn into CO2 and H2O. And when you write it, leave a little space in front because we're going to need to put in the coefficients. Now, I like to start with whichever is the most complicated looking molecule, and it's usually the fuel. The fuel, I say complicated looking because it has larger subscripts. And so I'd say 5 carbons. So I'm going to say I have 5 CO2s. That gives me 5 carbons on each side. I have 12 hydrogens on my reactant side. So that means I must have 6 H2Os on my product side. So again, I get 12 hydrogens. Now, I always leave my oxygens to the last because this number here can be any number of oxygens that I want it to be. So on the right side, I have 5 times 2, that's 10. 6 times 1, that's 6. Altogether, 16 oxygen atoms. So that would be 8 O2 molecules. So 1, 8, 5, and 6. That's my balanced equation. Now, the next one here I have C4H10. So we'll just get started. I'm going to put in some O2. This time I'm going to write H2O first just to show that it doesn't really matter what the order is. And I have 4 carbons, so I'm going to have 4 CO2s. 10 hydrogens, so I'm going to have 5 H2Os, so that'll give me 10 hydrogens on both sides. Count up my oxygens. I have 5 times 1, that's 5. 4 times 2 is 8. So altogether over here, then I have 5 plus 8, I have 13 oxygens. Now when I have 13 oxygens, that I need to have 13 oxygens on this side of the equation as well, my reactant side. And the way that I do that is writing an improper fraction, 13 over 2. Now if I needed a different number of odd number of oxygen atoms, then I would just write 7 over 2, or 9 over 2, or 25 over 2, or 1 over 2 if I only needed 1 oxygen atom. If I have an even number, I can just divide by 2, like I did before. 16 I had up here, and it turned into an 8. But if I have an odd number, just do the odd number over 2. That is only allowed with diatomic molecules like O2, Cl2, Br2. Everybody else, we'd have to go back and double. Now, it would be perfectly proper at this point to double the entire equation and use the numbers 2, 13, 10, and 8, and that would also be a perfectly good balanced equation. Okay, our next equation down here is CH3OCH3. Now, we will learn more about what the structure is, but this is a molecule that looks kind of like this. There's 3 hydrogens off of carbons, and the carbons are connected with an oxygen in the middle. That's called an ether. So if I wanted to burn it though, same thing, add some oxygen. I'm going to turn into CO2, H2O. And we can see on the left side, I have 1 carbon here, 1 carbon here, so 2 carbons. Even though the formula is written funny, we need to think of it as C2H6O. So our thinking would be that way. So say 2 carbons, so we know it's 2 CO2s. We have 1, 2, 3, 4, 5, 6. We have 6 hydrogens, so that's going to give us 3 H2Os. So we have 6 hydrogens on each side. And the same thing, here's our oxygens. So 2 times 2, 4 oxygens. 3 times 1, 3 oxygens. So we have 7 oxygen atoms on this side. So we need to have 7 on the left side. But here we have to remember that there is 1 right here in our fuel. So this is only 6 left over. So 6 atoms would give us 3 O2s. So our balanced equation 1, 3, 2, and 3. So the tips we said here is besides the normal kinds of equations, then don't forget that if you have an uneven number of oxygens, so we saw where we had 7 oxygens on one side, that you're going to need to use a fraction. So 7/2. Or you could go back and double the entire equation. Both of those are fine. Second tip is that when we get a compound, let's say we had something like alcohol, then 2 things. 1, notice that sometimes the atoms are not written together. Okay, so we have 5 hydrogens here, we have 1 hydrogen here, so there'd be 6 hydrogens. So we would think of this as C2H6O, but we have to recognize that. Second thing is that when we go back to write the number of oxygens for the O2, be sure and keep track that we have this one here. So subtract that. If we decide we had 7 oxygens on the right, here's one of them, so the other 6 would be part of the O2. So the idea is subtract the number of oxygens from that are represented as O2s. Still the same rule applies, the same number of oxygens on left side and right side. And those are combustion equations.